In continuation of the previous videos, this is again we are going to talk about the block diagram of the I/O interface only. So this is the block diagram of the interface. So we saw in the previous diagram here, we saw this is the full logic. This is the block diagram of the I/O bus and the interface and the peripheral. Okay, so here now we are going to see what is inside this interface logic. So inside this I/O interface, this is it contains some data bus buffers, and then it contains some registers. These are all the peripheral registers. Okay, so and then you have the registers, and then you have the timing and control. So the timing and control contains, you have these are all the control lines. So you have the chip select, you have the register select 1 and then register select 0, RS0 and RS1, and then you have the read signal and the write signal. So this is the timing and control contains all these signals. So you will see that there is a table here. So the three control lines, CS is chip select. So chip select, there will be a decoder circuit whenever the address is placed. The interface address is placed in the address bus. Then the corresponding, the lines will be connected to the chip select in a combination of these three. So if you see that whenever CS is 0, and whatever be the value of RS1 and RS0, whenever you have an X, this means it's a don't care, which means the RS0 and RS1 may be either 0 or 1, whatever it is. And when the chip select input is 0, it means that this particular interface is not selected, is not enabled. But for all the other inputs, when the chip select input is 1, then a combination of RS1 and RS0 will select any one of these registers. So when you have 100, it means that port A register is selected. When it is 101, then port B register is selected. And when it is 110, then control register. And when it is 111, you have the status register will be selected. Okay, so for selecting the whenever there is a this address bus will be the interface address will be placed by the CPU in the address bus, and you will see that the RS1 and RS0 will be connected to the least bits of the address bus. It will be directly connected to the least bits of the address bus, and there will be a decoder circuit here which will give the respective connections to the input data to the chip select RS1 and RS0. So based on the device address and the decoder circuit, the input will be placed in CS RS1 and RS0, and this particular interface will be selected when the CS value is 1. So when now the interface has got 4 registers. It has got a port A register, port B register. Now interchangeably port A, port B can be used. One register will be used for input purpose and the other register might be used for output purpose. So there is no convention whether port A should be an input register or and port B should be output. So any one can be used for input and one can be used for output. So here, suppose if port A is an input register, then you will have the data will be placed. 100 will be placed in CS1, CS, RS1 and RS0, and then since it's a input register, so a read IO read will be enabled and IO write will be disabled. So whenever a combination of these inputs, these signals are given, then what will happen is the data from the IO device there. So initially there will be a control command to check whether the IO device, whether depending on what is the IO device. If it's a tape, then to place the tape exactly in the correct place, move the tape and place it in the correct position. for the data to be transferred from tape to the register. So all those things we have already seen. So they were now when the input command is given, then you will see that CS RS1 RS0 will be 100 and a read instruction. This IO read will be enabled and IO write will be disabled. Then in that case, once when these signals are given, then port A will be selected and the IO device, the data will be transferred from IO to port A register first. Then there is an internal bus here. The internal bus is also, as I told you, a bus is also a group of wires. That's all. So there will be an internal bus, and from port A register, the data through the internal bus will be placed in the bus buffers. So the bus buffers are temporary. Buffer means temporary storage. So from the internal bus, the data will be transferred to the bus buffers, and from bus buffers it goes to the data bus, and from data bus it will go to the CPU. Okay, this is for the input operation. If it's a write operation, then you see that the port B register has to be selected. So the chip select input will be 1, RS1 will be 0 and RS0 will be 1, and IO read this signal will be 0 and IO write signal will be 1. So once when these signals are given, then so since it's a write information, so the data will be available in the bus buffers. From data bus, the data will be transferred to the bus buffers, and port B register will be selected, and the once when the IO device is ready, the status register will tell that the IO device is ready to accept the data. Okay, so then in that case, after checking whether the IO device is ready to accept the data in the bus buffer will get transferred through the internal bus. It will get transferred to port B register, and from port B register it will go to the IO device. So this is the overall function working whenever there is a control command is given, not an IO command. Then a control command is given. Control command is, to some function command. You may want to move the mount the tape, or move the disk to a particular position, or for a printer to calibrate the printer, and or to place the printer in a particular position. So there may be so many commands. So these commands, whenever the value, you see that whenever it is CS value is 1, RS1 is 1 and RS0 is 0, and IO read and IO write both will be zeros because it's a control command. So when these signals are given, the control register will be initiated, and the data will be whatever is the function code. The function code will now be transferred through the internal bus. It will get transferred to the control bus, and the device there will be a device controller. So the device controller will decode the type of command, and based on the command the device controller will actually perform the operation. Okay, it will either move the device forward, or it will rewind the device, or whatever is the command. So based on that, the device controller will perform the operations. Okay, so this is the overall thing. So as I told you, a command is passed to the IO device by sending the appropriate word to the appropriate interface register. Appropriate word means word consists of the opcode, the address, and you have the function code. So all the three together is your IO device, the word. Okay, transfer of data, control and status information is always through the common data bus. We saw what is the common data bus. So you have a bidirectional data bus, and you have an internal bus here. So this internal bus is what we are referring to, the common bus. Okay, so common data bus. Then the control register receives control information from the CPU, and the interface and the IO device is placed in a variety of operating modes. So whenever there is a control command, the control data will be placed to the control register, and the device controller will take action accordingly. Similarly, the bits in the status register are used for status conditions on for recording errors. So a bit in the status register might indicate that port A has received input data. So whenever the data has been placed, for if it's an input command, where for the data from IO device will be placed in the port A register. Okay, then the status will say that the data is present in the port A register. The CPU will issue a status command to check whether data has been transferred from IO to port A. So once when the data is already there, then it will issue a input command, and then data from port A through the internal bus will get transferred to the bus buffers and then to the data bus. Similarly, if it's a write command, then first it will check, it will issue a status command to check whether the device is ready to accept the input. So the device controller in turn will check the status bits in the status register to tell that the device is ready. So once when the device is ready to accept, then what will happen? It will issue it will issue respective signals so that the port B register is selected for output, and a IO write instruction will be given, and data will be placed in the bidirectional bus. So from the data bus through the bus buffers, it will go to the internal common bus. From there, it will get transferred to port B register, and then the IO controller will take from there. The IO controller will then transfer the data from the port B register to the device. So this is what will happen when an IO input and IO output, and the control register and status registers. Okay. So the interface registers communicate with the CPU through the bidirectional data bus. This we have already seen. Then the address bus selects the interface unit through the SIP select and to register select inputs. And an external decoder circuit is provided to select the particular interface. All these things I have already told you. Okay. So this is all about the IO interface.